Today we will study the next topic in the integration, and that is integration by partial fraction. So what is a partial fraction? First of all, I'll tell you, suppose we have got one of the fraction 3 by 7. I have got a fraction 3 by 7. I can write it down 1 by 7 plus 2 by 7. It doesn't make any difference. Now 3 by 7 have been simplified 1 by 7 plus 2 by 7. So it is basically the sum of these two is again 3 by 7. Like on the other hand, they have become quite simplified. So this is called the partial fraction. And already a fraction is there to divide into 2 or 3 and 4 fractions, and that they should be simplified. So this is what is called the partial fraction. So when to be used in the integration? In the integration, when we get some complicated fraction I mean to say, suppose there are px plus q, x minus a, x minus b. Now we are supposed to integrate this type of the fraction. So we don't have any of the kind of thing. So what we do, we write it down is equal to a upon x minus a plus b upon x minus b. Then we find the value of a and b. We find the value of a and b, and after finding the value of a and b, then the integration become very simplified. Otherwise it is difficult to integrate, but when we get the particular values of a and b, then they are quite easy to what is called you can find the integration. The next type is this is type first. I will give you, after writing the all types, then I will give you the illustration for each of these types. The second type we have, suppose we have got a kind of fraction. This is again px plus q upon we have x minus a into x square plus b. Now x square plus b is non-factorizable quadratic. It is a quadratic and non-factorizable. Here there was two linear factors. We wrote it down like this way. And I get a linear factor divided by one of the factor linear and other is a quadratic but not factorizable. Then how to integrate this? It will be written as a upon x minus a plus bx plus c and divided by our x square plus b. The only condition here, it is non-factorizable. Non-factorizable. When such a condition is there, then we write down in the numerator bx plus c, and then we find the values of a, b, c, all these. So this is our second type. Now third type. What is the third type of the question we come across, and that has to be resolved into partial fraction? I just tell you the type third. The type third is, suppose we have got, you can say repeated factors. Suppose we have got type 3 is your px plus q upon x minus a and x minus b whole square. Whole x minus b whole square means this is a repeated x minus b, x minus b. So then how to factorize, how to resolve into partial fraction? A upon x minus a and b upon x minus b plus c upon x minus b ka whole square. So this is the way. And such type of question where denominator has one linear factor, other linear factor, but repeated linear factor. Repeated means square is there. So then we will resolve such kind of what is called fraction into like this way: a upon x minus a plus b upon base x minus b and plus c upon whole, it is x minus b ka whole square. And after writing so, we find the value of a and b, c, and then it is there quite simple to integrate after we know the values of A, B and C. So these are the mostly what is called, we have got the three types of this one. Now let us start doing the certain questions. You will get the, you see, very much clarity after solving certain questions. So first of all, I solve the question second of exercise 7.5 of NCERT of class 12th. So now what is the question second says? This is a topic, integration by partial fractions. Integration by partial fraction. And the second question is our 1 upon x square minus 9 integrate this with respect to dx. Now, I told you in case we have got the linear factor in the denominator, it is a quadratic but factorizable. So, I can write down 1 upon 9 can be written as 3 square. The factor would be x plus 3 into x minus 3 by using the identity a square minus b square. So now this will be written, can be written as a upon x plus 3 and b upon x minus 3. Now what I do for finding the value of a and b, I will multiply both sides. This is a equal sign of equality. So both sides we can multiply with the same terms, etc. Yeah, same number, whatever. So I will multiply both sides with x plus 3 and x minus 3. When I multiply both sides by x plus 3 and x minus 3, this will get cancelled, will get 1. And a into x plus 3 will get cancelled, x minus 3. Plus b, x minus 3 will get cancelled. But naturally when we are multiplying both sides by x minus 3 and x plus 3. The same way we multiplied here also, and same way we multiply this one. So this get cancelled and we get b into x plus 3. b into x plus 3. So after getting this one, now I will tell you how to find the value of a and b. First of all, what I do, I make one of them to be 0. I know if I put up x is equal to 3 on both the sides, let put x is equal to 3 on both the sides. It will remain as 1, 3 minus 3 is 0, and this would be 6b. 3 substituted for this x, there is no x, otherwise there I would have substituted for x equal to 3, but because of no x, so I am putting x3 on both the sides. 3 minus 3 is 0, 3 plus 3 is 6. So b comes to be, the value of the b we are getting as 1 upon 6. So one of the value b we have received. Now for getting the value of the a, I will put up let x is equal to minus 3. Here I substitute x3, here I will put up x minus 3 just to make the b value of the b has obtained, to make it 0, minus 3, 3, 0. So what will be here? 1 is equal to minus 6a, or a would be equal to minus 1 by 6. So we have got both the values, b 1 by 6, a we have got minus 1 by 6. So now this question, it is the same one. When I resolve into partial fractions, so instead of a, what I can write down, we can write down minus 1 by 6. And instead of b, now we can write down 1 by plus 1 by 6. So overall, the question reduces to, the question, original question number 2 of 7.5, it becomes, what does it become? Minus 1 by 6 integration of 1 upon x plus 3 dx and plus 1 by 6 your integration of 1 upon x minus 3 respect to dx plus constant of integration. Now, so far our formula for the integration are concerned, we know 1 upon linear factor is equal to log of that linear factor. That is, its integration would be 1 minus 6 into log of x plus 3. Here again 1 by 6 into log of mod of x minus 3 plus c. So this is what we are getting the answer for this one. Or make it still simplify. Further simplification if you want to do, and if you know the basics of the logarithm, so the answer would be written as 1 by 6 is common from both the terms. I take out the 1 by 6 common, and then first of all I write down the positive term, that is log of x minus 3, then minus log of your x plus 3, isn't it, plus c. Now we know log of m minus n, log of m minus log of n is equal to log of m upon n. Log of m upon n. This is one of the property of the logarithms. This is one of the property of the logarithm ki one of the property it is. Now this further can be written as, what should I write it down now? It can be, the simplest form of this can be written as minus 1 by 6, or that is your log of x minus 3 divided by x plus 3 and plus c. Still make it to simplify. Minus means, the negative sign means minus 1. So one of the property of the log is your log of n m is equal to log of m to power n. This is another property of the logarithm. If I use that, so minus 1 will go up here. Minus 1 from here would be reaching here. Because n is minus 1, log m can be written log of m to power minus 1. Now negative sign to remove, make it positive. We do the fraction gets, we take the reciprocal of the fraction. So ultimately answer you can write down log of x plus 3 upon x minus 3 plus c. This is the final answer for the question number 2. Use two properties of the logarithm, negative sign, make it positive, and how to resolve into partial fractions, the you must do. So now let us go to the next important question of 7.5, and that is your next important question of your 7.5 is your question number 7. Question number 7, and that is question number 7, and here we have x upon divided by x minus 1 into x square plus 1. So now first of all I will resolve into partial fraction. For resolving into partial fraction, what I will be doing, a upon x minus 1. Now x square plus 1 is a quadratic, non-factorizable. So I told you in the beginning, so this type will be, how will you resolve into partial fraction? We write down bx plus c divided by quadratic which cannot be factorized. So this is the way. Now to find the value of ABC, I will multiply both sides by x minus 1 and x square plus 1. So what are we getting? Left side x or right side may this get cancelled, we get x square plus 1 and your bx plus c into x square plus 1 get cancelled, x minus 1. Now how to find the value of a, b, c? I simply clear the brackets, we get ax square plus a, and here bx square, then bx with the minus 1 minus bx, cx plus cx minus c. And further simplification may we get these two terms of x square, so we can write down a plus b into x square, or these are two terms of containing the both have the x with it, so it can be written as bx square, and this can be written as, if I take out the x common, we can write down c minus b, and at the end the two constant terms a minus c. Or on this left hand side we have got only single term x. Now we want the value of a, b, c. So what should we do? Here we are finding the value of a, b, c by comparing the coefficients on both the sides. Sign of equality is there. Both sides are equal. When both sides are equal, the coefficients of the like terms are also equal. And the coefficient of x square on this side, what is the coefficient of x square on the left hand side? There is no x square. That means 0 x square. So coefficient of x square a plus b would be equal to 0. That would be equal to 0. Or you can say b would be equal to minus a. So this is what we have got, one of the relation, b minus a. Now comparing the coefficient of x, here 1x, so that means c minus b is equal to 1. Or you can say c is equal to 1 plus b. 1 plus b. Or you better write down c minus b1, and then both are unknown. Let us go for the next one. Constant term on the left hand side, there is no constant term. So that means a minus c is also equal to 0. On the left hand side, 0 constant term is there. Comparing both sides, constant with the constant on the left hand, right constant, left constant equal, a minus c 0. Now we have got the three equation, a plus b 0, c minus b 1, a minus c 0. Three equations, three unknowns. We can find it out easily. How? I have converted b is equal to minus a. So instead of b, I can write down minus a. So minus b into minus a, it will become plus a. C, to convert the c also into a, I have right here a is equal to c. So for c, I can write down a. It becomes a plus a, 2a is equal to 1. So that means a is equal to 1 by 2. A is equal to 1 by 2. Just listen again. By comparing the coefficients, we got the three equations. We have got three equations. Coefficient of x square, a plus b. Coefficient of x square 0, a plus b 0, b is equal to minus a. C minus b, coefficient of x. Coefficient of x here 1. C minus b equal to 1. A minus c constant, on this side it is constant. So that is 0. Constant is 0, so a is equal to c. Now a becomes equal to c, b becomes minus a. Look, this equation converting into a totally, b minus a, here c is equal to a. Instead of writing c, a, and for b minus a, both become a plus a, 2a, a is equal to 1 by 2. When a is 1 by 2, c is equal to a. So that implies c is also 1 by 2. I got the value of c also. Now let us go for the value of the b. And b is minus a. So that means b is equal to minus 1 by 2. No. So this is the way we got value of a, b, c. All the three values from the three equations, we are able to find it out. Now let us move to the next one. Next, we just substitute the value of a, b, c in the original question. This was the question. Here we have to integrate. I resolve into partial fraction. Now it is purely partial fraction because I have got the value of a, I have got the value of b, I have got the value of c. I will substitute these values and then integrate it simply. Now putting the values for a, I am going to put, what is the value of a? 1 by 2. So substitute for a the value 1 by 2. A we have got 1 by 2. The quotient becomes 1 by 2 integration of 1 upon x minus 1 dx. Okay, the value of the A we have put it in. Now let us go for the value of B, and for value of B is minus half, and that is your integration of minus half x, value of C plus half divided by x square plus 1 respect to dx plus C. So now this is what we are getting here. So we are find the value of ABC, and I have substituted value of A here, and then value of B minus 1 by 2 and C plus 1 by 2. After knowing this one, just see how we'll integrate. Half 1 by x, that is your half of log of x minus 1 mod. So this we have integrated. Now there are two terms having the common denominator x square plus 1. I can separate them just as we take up the LCM of the two terms and then join them. Here we are taking it, the LCM must have been taken, and in the numerator two terms are there. We can separate them with the same LCM. That is, it can be written as minus half integration of x upon x square plus 1 dx. Minus half, this I have written, and upon x square plus 1. Then further half upon x square plus 1. Half this 1 upon x square plus 1 dx plus C. Now these terms are ready with us. This I have done integration. Here I observe x square plus 1 as we had done earlier, that is integration by substitution. This is a function, its derivative x square plus 1 is derivative 2x. If I multiply by 2 and divide by 2, here make it 1 by 4, doesn't make any difference. Now this is a function derivative. We can get the answer straight away. Here it is 1 upon x square plus 1. That is, we have that is the integration of 1 upon 1 plus x square is tan inverse x. So this answer, final answer, I am getting log of your x minus 1 minus 1 by 4 function upon derivative. Here x square plus 1 is a function derivative. So that means log of function, this one. Here half, or that is our tan inverse x plus C. So this is the final answer. This is the final answer. We can take out the 1 by 2, 1 by 4 common, there is no need. This is the answer is sufficient. In the board, you will get the full marks if you solve by this way. So now the next question, I am going to write down that the most important question, question number 9 of the exercise 7.5. Let us go to the question number 9. Now the next important question of exercise 7.5 is question number 9. What you observe? We see here numerator 3x plus 5, denominator is cubic polynomial having the power 3. And when we see it carefully, it seems to be factorizable. So we don't have any, I didn't tell you any formula where the cubic can be factorized. So let us see, it will be factorizable either into quadratics or into linear factors. So let us do 3x plus 5 divided by, common seems to be x square. When taken out x square common, we get x minus 1, minus 1 common, we get x minus 1. So now see further 3x plus 5, x square common, x minus 1, and that gives us 3x plus 5, x minus 1 common, and x square minus 1. Further, this x cube minus 1 can be factorized. So we may write down 3x plus 5 divided by x minus 1 square x plus 1. What I have done here, I have factorized x square minus 1 a square minus b square, a plus b into a minus b. So a plus b written here, a minus b, already x minus 1, x minus 1, 2x minus, any repeated factors we have got. We got the repeated factors right here. Now we are supposed to resolve into partial fractions where one of the repeated factor, another is simply a linear factor. So how to do? How to resolve such a quotient into partial fraction? Now just first of all you should understand that this quotient has been changed into this one, simplified into this one, not changed. We didn't change any quotient, this quotient, but simplified form is this one, which is ready to be resolved into the partial fractions. So now how to do it? So first of all I will do like this way, that is your 3x plus 5 divided by x plus 1 into x minus 1 square would be written as, can be written as a upon x plus 1 and b plus b upon your x minus 1 and c upon x minus 1 square. As I told you, when I told you earlier that three types, one of the type was repeated factors. So we have applied that formula, a upon linear factor, b upon base of the repeated, that is x minus 1, and c upon the whole repeated x minus 1 square. Now, to find the value of a, b, c, three unknowns, multiply both sides by the x plus 1, x minus 1 square. So we will be getting here 3x plus 5 is equal to a into, this will get cancelled and we will be having x minus 1 square. Now b into x minus 1 will get cancelled and we will get x minus 1 and x plus 1. C, x minus 1 will get cancelled and we get c into x plus 1. We are now supposed to find the value of a, b, c. There are two methods. One of them again, expand it, simplify it, remove the brackets and then comparing the coefficient. And the second quick method, because all the factors are linear factors, the quick method is here. I will take first of all x equal to 1 and in making one of the factor to be 0. When it becomes 0, a becomes 0. This 1, 0, b becomes 0. So we get the value of the c. So when x1 put up on both the sides, 3 ones are 5, 8. And on the right hand side, this 0, we get 2c. That is 2c. Or c comes to be 4. C value for the c comes to be your 4. Now, I made this 0, took up the x1. Now I will take up the x equal to minus 1. I will take up x is equal to minus 1. When I take up the x minus 1, this factor becomes 0, this factor becomes 0, and b and c, both the term becomes 0. Here minus 1, minus 2 square, 4. So it we get, or here on this side, minus 3 plus 5 is equal to minus 2 square, 4a. Or here from a we get 2 by 4, 1 by 2. So value for the a comes to be, and this is minus 3 plus 5, 2, 4a, a comes to be 1 by 2. I got the value of c and a. We are left with the value of the b. How to find the value of the b now? And now both two factors were involved. Both of them make them 0. I got the value of two constants a and c. Now I want to get the value of the b. What should I do for the b? I will compare the coefficients on both the sides. So which coefficient should I compare? I can compare either the coefficient of x or x square. The simplest is when I multiply these two. So what I will get, one of the factor will be x square, because x minus 1, x plus 1 is nothing but our x square minus 1. So when I clear the bracket, I get bx square. And when I expand it, a square plus b square minus 2ab. So one of the first fact will be a term x square. Multiply with this ax square. Here I get the bx square. So I get a plus b. Yani compare coefficients of x square on both sides. On both the sides. I get a plus b, and there is no term of x square on the left hand side. That means 0x square, or that is equal to 0. Or you can say b I am getting is equal to minus a, and a is half. So b is minus half. So this is the way I got the value of the b also. So two values I am getting by reducing them to zeros, and then b I am getting by comparing the coefficients. In this way, I got value of a, b, and c. All the three are known. All the three values of the ABC are now known to us. Now put up these values here and integrate. For that, I will just see how it will be done. We need the value of a, b, c to be substituted in the respective places, and that is equal to, for a, it will be written as 1 by 2. The quotient becomes 1 by 2 integration of 1 upon x plus 1 dx. For b, minus 1 by 2. So that is your, for b minus 1 by 2 and integration of 1 upon x minus 1 dx. Just erase it now. Now for the value of c, we have got 4. 4 upon x minus plus 4 upon x minus 1 ka whole square dx. Or 4 may you write down outside this one, plus c. Now this is the question has been resolved. When I just resolve the question into partial fractions, it becomes like this way. Now we can integrate it very easily. So how to do the integration of these term? Half 1 by x plus 1 will be written as half log of x plus 1, or minus half log of x minus 1, or this would be 4 integration of x minus 1 raised to power minus 2. So whenever you have to integrate of such type of what is called quotient, your function, that is 1 upon x minus 1 raised to power 2, 3, 4, etc. We just take it to the numerator and make it the exponent to be negative 1. Now, integration of this would be our 4 plus 1 upon plus 1. That is x minus 1 raised to power minus 1. In the denominator also it comes to be minus 1 plus c. The overall answer we are getting half of log of x plus 1 minus half log of x minus 1, and this negative sign would jump to here, we get minus 1. So this is the final answer. Or it can be written in the denominator if we want to make it positive. For making it positive, I can write down 4 upon x minus 1. 4 upon x minus 1, it become positive. So this is the answer for the question number 9. So these are the most of the important question of this exercise. So now we will doing the our now the next important question will be doing of exercise 7.5, that is question number 17. Now just observe, it contains the trigonometric terms. It contains the trigonometric terms, while right from the beginning of the 7.5 we are doing the algebraic terms. So now we will straightway to resolve the trigonometric term into partial fraction is not an easy job. So what we'll do, we'll convert into an algebraic terms. How? Let me put sin x is equal to t. If I substitute sin x is equal to t, so now what does it becomes? It becomes your cos x dx. Sin x, say we get cos x dx is equal to dt. Cos x dx is equal to dt. Now the quotient reduces to our cos x dx dt 1 upon 1 minus t, because sin x have been taken as t, 1 minus t, and into 2 minus t. So this is what we get here, and with respect to dt. So I change into the sin x, let t, cos x dx dt, cos x dx dt 1 minus t, 2 minus t. So this is the question, our algebraic form. I can take the minus common from both the sides, it becomes still easier. That is your 1 upon t minus 1 into t minus 2 respect to dt. So this is the question become, because two negative signs taken, product of two minus into minus becomes positive. So I taken it from minus, from 1 minus t and 2 minus t, both the negative signs multiplied become positive. So the question become like this way. Now to resolve into partial fractions, what I'll do, let a is equal to t minus 1 and our b is upon t minus 2. Again, as the methods have already we have done, we will find the value of a and b. So multiply both sides by t minus 1, t minus 2. So I get here 1 is equal to a, t minus 1 get cancelled, a into t minus 2 and b into t minus 1. To get the value of, now we are supposed to get the value of a and b only. To get the value of one of them, I take up the let t is equal to 1. If I put up t is equal to 1, 1 minus 1 0, b becomes 0. Here I get, what I get, 1, left hand side 1 is equal to t is your 1 minus a, or a will be equal to minus 1. So what now the values I get, that is equal to a is equal to minus 1. By letting the t is equal to 1 let kiya gaya, this have been let t is equal to 1, we get a minus 1. Now after this one I let t is equal to 2. When I have taken let t is equal to 2, so what we get, 2 minus 2 becomes 0, 1 on this side, 2 minus 1, 1. So that is 1 is equal to b, or b is equal to 1. So this is the value. So here we get the a minus 1, b 1. Now this whole of the question becomes, क्या बन जाता है हमारा, a minus 1 minus 1, minus here 1 I return, or b is b, for b we can put out the value 1, this one. Already we have done the respect to dt, it is respect to dt and dt. So this is the question. We are able to get it. 1 upon t minus 1 brought out from here. From here we have brought it here. 1 upon t minus 1, t minus 2 respect to dt, sin a cos dx dt. We have taken this question, get resolved to this one. So ये question हमारे पास, it becomes like this way, 1 minus t so and so, this one, this one. Now we are supposed to integrate these two. So for integration, now it becomes very simple. It is in the algebraic form. The variables have been changed from sin x to t. So now how to integrate this one? कैसे हम integrate करेंगे? Just look at this. So minus 1 upon t minus 1, integration of this would be our minus log of t minus 1 plus log of t minus 2 plus c. But what the t was taken? Sin x. So ultimately answer comes to be minus log of sin x minus 1 plus log of sin x minus 2 plus c. So this is the answer we are getting here. So this answer can be written other way also, by taking out the common etc. minus 1 minus sin x etc. But this is the correct answer. You should write down this way. It will be quite. Or further simplification, I told you log of sin x minus 2 minus log of sin x minus 1 plus c. We know the property. What is the property we have with us? That is log of m minus log of n is equal to log of m upon n. So what we have? Log of m minus log n. So log, this is taken to be m, n. It can be written as log of sin x minus 2 upon sin x minus 1 plus c. This is the final answer for question number 17. So now let us go to the next important question. Or here just see, this was a question containing the trigonometric functions and we are able to solve it with the help of partial fractions. Similarly, many other questions with the trigonometric terms can be solved with the help of our partial fractions. The next important question of exercise 7.5, I take up the next question, and your question number is you can say our 23rd question. What does it tell? 23rd, integration of 1 upon x square plus 1 dx. We have got 1 upon x into x square plus 1. Again, what do we have? We have denominator में two terms. One is non-factorizable and other is a linear factor, simply x. So for partial fractions के लिए, we can write it down a upon x plus bx plus c upon x square plus 1. Now, first of all, resolve into partial fraction this question. So what I'll do, multiply both sides by x into x square plus 1. If we multiply both sides with x into x square plus 1, what will be getting here? 1 on this side, a into x square plus 1 plus bx plus c into x. Further simplification will give us ax square plus a this with this one, and bx with x, that gives us bx square, and this plus cx. And what I have done it? I simply clear the bracket bx plus c, x got multiplied with the bx and c. Now this further can be written as, we have got two terms of the x square, दो terms है x square की, let us take out the x square common, a plus b into x square, and then comes the terms of x, then the constant term a. Now we want the value of three unknowns a, b and c. If I compare the coefficients, comparing the coefficients of x square on the left hand side there is no x square, that means 0. So coefficient of a plus in x square would be 0, a plus b is equal to 0 first. Then x, again c comes to be 0 because there is no term of the x on the left hand side, so c is 0. Or constant a1, the value for the a comes to be 1. Now c we got, a we got, value of b is equal to minus a, and a is 1, that is minus 1. So we get the value of the b to be minus 1 and a to be 1 and c is equal to 0. Now let us substitute this value right here. So what we obtain after writing these values here, it becomes like this way, 1 dx. For a, I am going to write down the value of a and minus 1 upon x respect to dx. Or for b, I am going to write down, for a, I have written, a should be 1, a is 1, positive 1, it becomes 1 by x, and our b is equal to minus 1. So that is integration of minus x plus 0 upon x square plus 1 dx. So these are the value after putting the in the question, given question, the question has been resolved into partial fractions. So this is the value of c is equal to 0. Further it becomes 1 by x dx, minus comes up here, x upon x square plus 1 dx, 0 upon 0, plus c. Now integration of 1 by x is log x, because we know since 11th derivative of log x is 1 by x, or integration of 1 by x is equal to log x antiderivative. Here by substitution we know this is a function and its derivative. So simply multiply by 2 and divide by 2. So it question now the integration would be x minus half log of x square plus 1. Why? This is a function and derivative. So whenever there is a function and its derivative, for example, we have got, what you suppose you have got your function is in the numerator, denominator में function है, तो we have here fx divided by f dash x, or fx here and f dash x is here, dx. Function t लिया, derivative dx dt, and its answer can be straight away written as log of fx plus c. This is what I have done here, x square plus 1, 2x, or the log of x square plus 1 plus c. So this is the answer, log x minus, or it was a multiple choice questions, or I think it is your answer is A, that is log x minus half log x square plus 1 plus c. So this is how I finished the exercise 7.5, and the most of the important question have been done. Or thank you very much. The next.